Hey everyone! Our project topic is Performance Comparison and Application of Large Language Models in Financial Regulation Question Answering Systems. We will present our project in 5 parts: research motivation, research framework, model comparison, web demonstration, and conclusion with future prospects. Let's start with part 1, research motivation. As AI technology continues to advance, large language models like ChatGPT and Llama have been widely used in areas such as machine translation, text summarization, and automated question answering. However, in professional fields like financial regulations, we still face issues like massive amounts of legal texts, specialized terminology, and complicated structures. At present, question answering systems often face 3 major problems: inaccurate understanding of meaning, irrelevant search results, and incorrect answers. Next, let's move on to part 2, research framework. In the data pre-processing phase, we had 3 major steps. First, we use web crawlers to download PDF files from the FSC's Financial Regulations full text search system. Then we filtered the files by topics like fraud prevention, fintech, and financial holding companies. Lastly, we made sure all PDFs were converted into plain text and had ChatGPT generate question sets based on their contents. Here's the research framework for our project. We designed 3 experiments using RAG alone, fine-tuning alone, and a combination of fine-tuning with RAG. To compare the models, we evaluated their performance at each stage using sentence-level semantic similarity measurements in Chinese. Based on the results, we selected the best performing model for our question answering system. This is the workflow diagram for RAG. After the PDF files are processed and split into text chunks, the chunks are vectorized and stored in a vector database. When a user inputs a question, it is also converted into a question vector. Both the question vector and the relevant vectors from the database are then passed to the large language model to generate a comprehensive answer. Next is the workflow diagram for fine-tuning. First, we use the prepared question set based on financial regulations as the training data. Then, we select a large language model to fine-tune and apply the LoRa algorithm for low-parameter fine-tuning. Finally, the fine-tuned model is used to generate answers. Now let's move on to part 3, the results of our model comparison. Let's quickly introduce the 4 models we used. TIDA is a traditional Chinese large language model developed under the National Science and Technology Council. Taiwan Llama is built on Llama 3.1 and fine-tuned with traditional Chinese data. Mistral is a lightweight open-source model from France. And finally, Llama 3.1 is a fully open-source model that supports multiple languages. Next, we will present the results of the 3-stage experimental design, starting with the RAG stage. From this chart, we can see that the semantic similarity scores of the 4 models are quite close. The highest score was achieved by the TIDA model, reaching a semantic similarity of 0.5950. Here are the results from the fine-tuning stage. We observed that the overall model performance was lower than expected, with a decline in semantic similarity scores. Although Llama 3.1 was the best performing model in this stage, its semantic similarity dropped from 0.5940 in the RAG stage to 0.5726. Finally, we have the stage combining RAG with fine-tuning. In this stage, the best performing model was Mistral, achieving a semantic similarity score of 0.5947. Although we originally expected that the models in this stage would achieve the highest semantic similarity, the results showed that the best overall performance across all 3 stages was still achieved by the TIDA model during the RAG stage. This chart shows the comparison of the overall performance scores of the models, where a lower score indicates better performance. From the chart, we can see that TIDA and Mistral achieved the best overall performance across all experiments. Now moving on to part 4, the demonstration of our web-based question answering system. Upon entering the question answering system, users will first see 2 options on the homepage: register and login. First, we click on register and use the account 123s and the password 123 to complete the registration. After completing the registration, the system will automatically redirect to the login page. Next, we log in using the account 123 and password 123 that we just registered. After successfully logging in, users can access the menu on the left to update their personal information settings. On the Personal Settings page, users can change their profile picture. By clicking on Change Avatar and uploading an image, the profile picture can be successfully updated. On this page, users can also update their account name and change their password. Here, we will demonstrate an error detection example. If an incorrect old password, such as 456, is entered, the system will display a prompt saying, "Incorrect old password." After re-entering the correct old password, 123, the password can be successfully updated. Finally, we will demonstrate the operation of the question answering interface, which uses the TIDA model from the RAG stage. We enter the question into the message box and click Submit. After a short wait, the model will generate a response. In this demonstration, we completed a total of 3 question and answer examples. Finally, let's move on to part 5, our conclusion and future prospects. First, we initially expected that the combination of RAG and fine-tuning would achieve the best semantic similarity performance. However, we found that simply using the RAG architecture already provides a decent level of semantic understanding. Second, fine-tuning does not necessarily improve semantic performance. In the second stage of our experiments, the average semantic similarity scores of the 4 models dropped by about 0.04 to 0.05. Third, the combination of RAG and fine-tuning does not always produce a synergistic effect. Although the Mistral model achieved the highest semantic similarity in the RAG plus fine-tuning stage, it still did not outperform the TIDA model from the RAG-only stage. In the future, we plan to continue our efforts in the following 5 directions. First, enhancing semantic evaluation methods by incorporating more diverse evaluation approaches. Second, experimenting with different fine-tuning techniques. Third, improving the RAG architecture by adding multi-round retrieval or integrating knowledge graphs. Fourth, developing a multi-module question answering system that combines functionalities such as summarization and classification. Fifth, conducting real-world testing by inviting financial industry professionals to use the system and collecting their feedback to upgrade the question answering system. This concludes our project presentation. Thank you all for your attention.